For loops are so passe. Let's use a different technique to loop through a list. Welcome to this quick hits video. My name is Kevin Fiesel, and I am the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Python has a couple of methods for iterating through a collection, such as a list, a dictionary, or a set. The easiest technique to understand is a for loop, but it turns out that there is a terser way to get to the same end location. Let's go to the classroom and learn more. A common requirement in Python code is to take some list or other collection, perform some action on it, and generate a new collection. In the functional programming world, we call this operation a map. Before we go too much further, Python does have a map function that behaves similarly to what I just described, but we are not going to cover it in this video. I do have an interesting link in the description below that compares the map higher ordered function versus what we are going to discuss, but that's something you can check out later for extra credit. Now, onto the solution we're actually going to cover. When it comes to operating over a collection, the language snob in me would like to see a pipe forward operator, like we see in languages such as F#, but Python has a different solution in mind. Instead, in Python, we use the notion of comprehensions. There are three types of comprehension we will cover today: list comprehensions, dictionary comprehensions, and set comprehensions. All three of these behave somewhat similarly, though the syntax is a bit different for each. Let's start with the simplest of the three, list comprehensions. This, at its core, is a very simple list comprehension. We use square brackets to denote that our result will be a list. Inside the brackets, let's start on the right-hand side, which is our iterable item. In this case, we are using a range that runs from 0 through 9 inclusive. Directly to the left of that, we define a temporary variable, I, which represents each individual item in our iterable object. Finally, going all the way to the left, we define what we want to do with that temporary variable. In other words, the result of this, which we put into res, is a list with elements running from 0 through 9. This is an incredibly simple example, but we can, of course, build from there. For example, suppose we want to perform some mathematical operation on each I, such as adding 5 to it. When we resolve this line of code, the result is exactly what you would expect. We can naturally do more with this than just mathematical operations. And in fact, we don't even need the inputs if we're more concerned with the shape of the output. In this case, I am creating a new list and populating it with the value 1, regardless of what the value of our current item is. To indicate this to developers, we can use the underscore here, as that shows we are not going to use this variable, so we don't even bother giving it a name. We also have a powerful filtering capability with comprehensions. This operation first checks to see if the value of our variable I is even. If so, we then add 5 to that number and return it. Our result set is smaller than the initial list, as we filtered out all of the odd numbers. But lists aren't the only thing that we can generate. We can also generate dictionaries and sets. In order to generate a dictionary, we've got a slightly different syntax. In this case, we have a dictionary called my_dict. This dictionary contains a series of key value pairs. In order to iterate over each key in the dictionary, we use the items method to give me back a series of tuples. I can do whatever I'd like to these keys and values, and the curly braces around this indicate that we are going to end up with a dictionary at the end. Okay, this is kind of dumb, but what if we want to lowercase all of the keys and convert the values to integers? Well, that's pretty easy, and I don't even need to start with a dictionary. I could start with a list of keys and then generate the values, or even use these as values and generate a new set of keys. And now we need a set comprehension. As a quick reminder, a set is a mathematical construct in which each element is unique and there is no explicit ordering. The following code generates a set out of some iterable. This looks very much like a dictionary comprehension in that we use curly braces instead of square brackets. But we can also see that there is only a single value, not a key and a value. This is how Python knows that the output of this will be a set rather than a dictionary. We've seen some generic examples of these three types, but now let's jump into a demo and watch it all in action. Here we are in Visual Studio Code. I'm going to start with something very simple, a range of 75 values spanning from 0 through 74. It's not a particularly exciting starting point, but it will do for our purposes. Let's start with our simple list comprehension. This code will iterate over the range and generate a new list. Incidentally, if you ever have an iterator or generator, this is an easy way to convert that into a concrete set of results and print them out. In the next example, I'm going to return only the even numbers. As you can see, we skip any odd numbers, just as you would expect. The if clause here is how I'd like to indicate that I want a filter. But what if we want a more complex filter? Well, we can have multiple conditions. Suppose I want only even numbers greater than 50. Running this, we can see the results range from 52 through 74, just as we would expect. But what if we want to cap the numbers below 70? This bit of code will work just fine. If we want an or condition, we can do that as well. Do note the parentheses here. This states that I am happy if we meet one of two conditions. Either the number is cleanly divisible by 7, or the number ranges between 20 and 30 inclusive. Running this, we see the set start with 0, 7, and 14, and then include everything from 20 through 30 before picking back up again with 35 and 42. You can specify lambda expressions or even full functions in a comprehension. For example, let's define the function is_even, returning true if x is even and false otherwise. Then we can reference this function in a list comprehension, returning our even numbers. And we can even make the function call arbitrarily complex. In this next example, I'm going to return true if the incoming number is even and the result is greater than 50. Running this code example, we see the resulting list start at 52 and go through 74. This also works if we want to combine functions with standard expressions, such as calling the isEven function and including a secondary filter where x is less than 30. Moving on, let's create a simple dictionary containing some names of fruits and numeric values that we'll say represent the price. By the way, before I paste this in, I'm going to press the F3 key on my keyboard, as it turns out that as of Python 3.13.1, there is a new interpreter, and if you press F3, it will put your code into paste mode, making it easier to paste in longer blocks of code without error. This even lets you include functions with new lines in them, something the older interpreter did not support very well at all. When you're done with paste mode, press F3 again, and it switches you back to the normal interpreter mode. With that quick demo out of the way, I'll get back to our normally scheduled broadcast. Let's say that I want to operate over each item in the dictionary and generate a new dictionary based on the results. To do this, I can use the formulation for a dictionary comprehension. I start with curly braces around my comprehension. Then I'll define my key and value, separating them with a colon. The terms fruit and price come from the key and the value, respectively, of some dict. But note that we cannot simply iterate over the dictionary itself. Instead, we have an items method that returns a view object, and we can iterate over that view object. Finally, I'll add a filter and indicate that I only want the dictionary items whose prices are over 30. Just as with list comprehensions, our filters can be arbitrarily complex and can include operations like and or. We can also use functions to define our filter criteria, just like with list comprehensions. We can even define functions to operate on our keys and values, not just filters. In this next example, I am going to define a function called standardize fruit key, which takes in the fruit name as the input. Our function is fairly simple. It lowercases the fruit name and replaces any spaces with underscores. This function is simple, though you can make it as complex as you need it to be in order to solve your problems. If we run the comprehension and print out our results, we can see the lowercase fruit names and that there is an underscore between the words red and cherry. The third type of comprehension we'll look at is a set comprehension. Set comprehensions also start with curly braces, but instead of having a key and value pair separated with a colon, we have only the set item, which in this case I've made the price. Notice that as I iterate over the dictionary's items, I do collect both the fruit and the price, but Visual Studio Code grays out the fruit variable, indicating that I don't actually use it anywhere. For that reason, we can replace that unused variable with an underscore, telling Python and future developers that we don't actually care about the key, and removing it is a conscious decision on our part. The end result is the same, but the logic is more explicit. Finally, we don't need to start with a dictionary. We could start with any list, iterator, generator, or other collection that you can iterate over. Here I have a range from 0 through 74, and we'll generate a set of even results. Before we wrap things up, I want to perform a quick test of performance to see how comprehensions do versus for loops. In this case, I will generate 10 million numbers. My plan is to include only the numbers that cleanly divide into 7, and we can see the logic for the for loop versus the list comprehension. The list comprehension is a bit terser, being a one-line operation versus 5 lines for the for loop. But if the for loop is considerably faster, who cares about a few extra lines of code? So let's test this out and see which is the champion, or even if there is a difference between these two. This will not take too long to complete on my desktop here, so I don't need to vamp that much. Instead, we will see the results pretty quickly. In my testing prior to recording, the for loop would take approximately 1.3 seconds, whereas the list comprehension would be slightly under 1.2 seconds. That's not a massive difference, being about 100 milliseconds, but it is repeatable, it is consistent, and that indicates that comprehensions can be slightly faster than or equivalent to for loops for this kind of work. That's going to do it for comprehensions. This is a small but powerful bit of Python syntax. I will say that I do use plenty of for loops and even the map function in Python, so this is not a full-on replacement for those solutions. In particular, we can use for loops for statements, whereas comprehensions are expressions. What I mean by this is that comprehensions always return a specific data type and structure. We don't have a choice. If you use a list comprehension, you're always returning a list. By contrast, I may return some data structure from a for loop, but there's no requirement for me to do that. We'll have links and show notes in the description below. And until we see each other in the next video, take care.